Wolfram, European Chief Executive and co-founder of Wolfram Research. We make lots of computation technology, Mathematica and Wolfram Alpha. But I'm really here as the founder of computer-based maths to fundamentally fix maths education.
And I'm Gavin O'Mara, I'm here from FE News, and I'm here to talk today with Conrad about two things, the future of delivery of maths in further education. But the first thing I wanted to speak about was how to make maths more engaging for learners and how to make them more job ready and to make basically the learning more relevant, basically.
Well, I think the thing you've really got to start from is how is maths used in the outside world? What does it do for us in real life? And maths is used so many places in the outside world, but it's used with computers doing most of the calculating, not with humans doing most of the calculating. And so what we've got to start from to change how maths is, because most people think maths when they come out of school, they think, gosh, I never use this in my life. I might do a bit of arithmetic, but I don't really do much in terms of any higher level maths. So what we need to start with is, where is the maths really being used? Let's take real questions and problems from real life that people really will encounter. Let's take them back into the classroom and let's apply the complex mathematics that we need to apply, but using computers to do the calculating. So rather than learning by hand how to solve equations or multiply long, big numbers or do long division, instead we should be learning how to do data analysis, for example, using a computer. It might be 100,000 data points, or it might just be, how to do different bits of geometry, but using 3D geometry on a computer. So really maths, you need to think about maths as a way to solve problems. It's one of the world's best problem-solving systems. In order to do that, you sort of go through steps where you try and define the question that you're really trying to ask. Then you sort of abstract it into this way of sort of describing it in maths. And that allows you to solve it and calculate the answer. And then you can sort of, step 3 is that calculating, and step 4 is to go back from calculating to sort of the real answer that you tried to, the answer to the question you first came up with. And if we can get step 3 to happen with computers, then we can do really harder questions. We can do much more fuzzy contextual questions. And a lot of the things in the FE sector that are being done with maths, or should be done with maths, are actually things that are in a way using harder maths than you do in some of the traditional sort of university courses on maths and so forth. And that actually requires more computing power, not less. And that's why it's so crucial that we allow people to use computers for doing that. So what we're doing at Computer-Based Maths is to try and build new curricula based on the idea of allow a computer wherever you want to do the calculating to be used, build out from that what you would do and ask real questions and try and use maths to solve those questions. And also use coding, because the way that you write down maths in the modern world is with code. And that's the real connection between maths and coding, is that coding is in a sense the way you write it down so you can get the computer to do it. So coding really fits with this idea of maths. Well, as you can imagine, trying to decide what you should do in a modern maths environment and what you should, how you can make that work is really quite hard. People have been trying to do this for a long time. And so it's great that we have contributions from many people. And one of the ways we do that is we're hosting a summit in London coming up in November. The idea of that is really to put together all the stakeholders of maths from whatever walk of life. Absolutely not just mathematicians. We want people who are using maths or want to use maths or want to learn maths. And we're trying to put that together and figure out what exactly is it that this subject should be and how can we get that across. So I hope many people watching this will be able to look that up and maybe come to it.
Sounds really interesting. It'd be really good to maybe have a follow-up after the summit, actually, to see what's the outcome from the whole day, actually. Could we talk about the future as you see it for maths delivery in further education, basically?
Yeah, sure. So, I think further education is very into these practical problems, which can be, used with maths. And so I think what we need to do for that is build, in a sense, modules which sort of represent some of those example problems. What I want people to be able to do is get hold of a real problem so they understand what it is they're trying to figure out and work back from that. Hopefully we can pick problems that they'll face in their real lives every day. And in different industries, whether it's finance or whether it's you know, data. Everybody's going to deal with data analysis to some extent, whatever they're doing. And so pick those from the different sectors, build out modules and storylines, and then show how the mathematics attaches that. So in a sense, you lead with the problem. You then get the mathematics to help you out where you want to solve that problem. You know, it's really useful to have a few hundred years of thinking behind how do you get from a question to an answer, as long as you can set it up that way. So we're working hard to build sort of interactive, in a sense, they're interactive modules. They're like interactive textbooks that work both for the teacher and for the student, and the sort of combined delivery platform, which allows interaction across these problems. You know, a mixture of sort of little quizzes and things to move you forward and primers. And we're slowly starting to build those out. They're not quite ready yet for deployment everywhere, but we're looking for groups to help invest on building this this content so that we can really have it ready for every sector and very much for further education. It'd be great to add, you know, even if you've had a terrible time with maths at school, when you come to FE and look at it, just take a fresh pair of eyes, think about maths as just a way to help you solve problems. You can solve problems by talking about them in English, or you can try and solve problems with the help of maths. And instead of thinking of it as this very abstract way of doing things, think about it as a way that you can turn sort of everyday real problems into these special abstract ways to represent them, which allow you to get answers to those real problems. I think a lot of people just think mathematics is this weird abstract thing, can't see how it relates to what they're doing in their life, and then think it's therefore no good. So, and also, it's good to think about the setup of the problem versus how you calculate that problem once you've set it up. And often people get a bit stuck on the setup, and it's the setup that can really help them. Use whatever you want, equations, any way to lay it out, and then try and figure out how to get the computer to solve it. Don't worry too much about how to calculate it yourself. I think if you can get the idea of maths clear and not be too frightened by it or put off by it, it can really be very, very helpful. And we've actually got a poster that you can download to summarize how the maths process works and how you can get more out of it.